So today my project title is Predicting Concrete Compressive Strength and Analyzing Material Patterns Using Machine Learning. Hi, this is Vamshi, and so today we'll be covering regarding this. And to start with the introduction of this, we need to understand why concrete plays a major role in the construction management, and also our objective being using the machine learning to predict the strength, identify the material patterns, and improve the decision making in mix design and defective detection. So coming on to the abstract, now as we said, we are predicting the concrete compressive strength based on the material composition and the curing age. So there are many number of methods that could be done, and with our data set whatever we have. So in this particular project, I'm using linear regression, random forest, and k-means clustering patterns to identify the best one, and and use the use the classification models and come up with the analysis to align with the objective that I have discussed. So as said the introduction, the concrete is a critical material and a valuable material to known for its versatility and strength. And the objective here is to predict the compressive strength using linear regression and random forest models, then followed by discovering the material compositions using k-means clustering, then ensuring the reliability through robust analysis and validation, then classify the concrete mix and develop a CNN framework for defect detection in the concrete structures and use a network data analysis to the model. So this is our data. So the data has around 1000 records describing the concrete mixes, which could be cement, blast furnace, fly ash, water, superplaster, then fine aggregator, age, and target. So these are the deciding factors which has dependent and independent variables to make the decision and align to the objective. And the methodology that we are taking, because it's a machine learning model that we are going ahead with, so we need to understand and follow the methodology there. So firstly, followed by starting with the data pre-processing, where we standardize the features and analyze the correlations by generating the maps. The maps could be something like this, where you just create a correlation matrix and identify the things, and followed by the regression models. As said, we are using linear regression and random forest, and with respect to clustering, we are using k-means and PCA for visualization, and we'll be doing a comparative study between which model is best and best fitted here for according to our data set, so that we can achieve the objective whatever we have discussed in the introduction. So the next followed by the classification. So logistic regression for binary classification, for image classification, have used a CNN, basic CNN for defect detection, and followed by the network data analysis. So there we are using a KNN graph for material dependencies. So these are the results. Before going to the results, I also want to take some time to discuss about the k-means clustering, where we have divided the data set whatever we have into 3 clusters based on the composition and the curing ages, where there are 3 clusters here. If you can say the color difference shows the number of clusters here, and we have reduced the dimensions to visualize in a 2D space for a better visualizations though. And after the model training, from the results, what I observed is like regression having a MEA, which is mean absolute error of 7.7 megapascals MPa, and R square is 0.75. For random forest it is 4.32 MPa and 0.9. So clustering, three clusters were identified as I've said, and we got a Cellular score of 0.22, and our classification model gave us accuracy of 89%, which is indicating a very good model and a very good data set and a clean data set that we have, and the operations that we have done on the data set is proper. So it's not a very great model though, but we have achieved a good accuracy there. So coming to the future work, we can really use a complex data models or the data networks. Like we can have a CNN model being trained and using in the real world for defect detection, because the number of factors that could influence for particular variable, let's say now we have around like 13 columns which decides a concrete strength, but in a real time scenario it's not just the 13, but there could be more number of dependent variables to decide the output. So in that case we need to have more robust CNN network. And also uh, when we have a robust CNN network, it's also very needed that we need to have advanced clustering methods like having a DB scan, density based scanning, then hierarchical clustering. So and we can also expand the network analysis and modify the workflows though. And here uh, from the objective that we have started with, the machine learning effectively predicts the compressive strength and identify the material patterns as I've discussed, which is detailedly given in the report. And these are the results. And followed by the conclusion, where from the conclusion it's clearly evident that the random forest outperforms linear regression in the accuracy. So it is with respect to this data set, and it could again vary based on the data set, and the conclusions are from the data set being taken. And clustering reveals the actionable insights of for a mixed design optimization. Classification and CNN models expand automation potential in crunch construction, which is very important point which I have discussed in the future work, which is part of the future work. And network analysis brings a new perspective on material. And that is pretty much. So yeah, and these are the references that I have taken, which is from the Kaggle. The dataset was taken from the Kaggle, and there are some blocks which are more aligned to the network science. So the reason being, we need to have in order to make a network analysis study, we need to know what is a network science. And also like the basic core of thing, which is like concrete strength. What do you really understand by concrete strength is what I refer to. So I have just included even that as a reference. Thank you there.